The understanding of sine wave is significant because this wave pattern occurs often in nature, including wind waves, sound waves, and light waves. A sine wave is a geometric waveform that oscillates periodically. Let's dive deeper into the formation of a sine wave. Suppose we have a circle whose center is at the origin of the x and y axis, and which has a radius of 1 unit. And we draw a line from the center of the circle to some random point on the circle. Let's call the angle that this line makes with the horizontal line as theta. We then vertically connect this point on the circle with the horizontal line. Let's call the length of this line as h. Now we see that we have a right-angled triangle. Let's see this right-angled triangle from the angle theta perspective. We know that sine theta is equal to height upon hypotenuse. In this case, the hypotenuse is the radius of the circle, whose length is equal to 1 unit. Hence, we can replace hypotenuse with 1. As in this case height of this right-angled triangle is h, sine theta becomes equal to h. As we change the value of the theta between 0 to 360 degrees, the height is changed between the values 1 and -1. For example, at an angle of 90 degrees, the value of h is 1. At 120 degrees, the value of h is 0.87. At 250 degrees, the value of h is -0.94. And so on. Let's plot another graph where x-axis now represents the degrees of this angle. This graph represents the value of h on y-axis for each degree of theta on the x-axis. Let's change degrees with radians. If we see this equation with respect to the sine wave, h is measured on y-axis. So, we can replace h with y. Theta is the value of each degree on the x-axis. Hence, theta can be replaced with x. On rearranging, it becomes y is equal to sine x, which is the function of the sine wave.